Thank you for joining us on exercise 3G. I'm going to be looking at question 3, part B. Find the real numbers a and b that satisfy the following: a plus bi over 1 plus 2i equal negative 3 plus I. Well, we're going to leave the right-hand side alone. We've got a real component of negative 3. We've got an imaginary component of 1. But let's work on the left-hand side. So I'm going to take the fraction a plus bi and 1 plus 2i and multiply it by the conjugate of 1 plus 2i. So that means instead of 1 plus 2i, it will be 1 minus 2i, and we'll put that on the numerator as well. So we don't change the fraction. Whatever you do to the denominator, you do to the numerator. Now let's expand each of these. So we've got a, we've got minus 2ai, we've got bi times 1, so that's just bi. And we've got bi times negative 2i, so it's positive, so it's negative 2bi squared. Now for the denominator, 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is plus 2i. And 2i times negative 2i is minus 4i squared. Now the right-hand side is still negative 3 plus I. Now we've got this two terms with I squared, and I squared is negative 1 in complex numbers. So negative 2bi squared would be negative 2b times negative 1, and that becomes positive 2b. And on the denominator, negative 4i squared becomes negative 4 times negative 1, becomes positive 4. So let's change those. So we've got a minus 2ai plus bi, and that becomes plus 2b. And we've got a 1. Now these cancel, minus 2i and plus 2i. So we change minus 4i squared into positive 4. All right, we're almost there. Now, let's bring the real, let's put it all over 5. I'm going to take this 1 plus 4. I'm just going to make that 5. Make it easier right now. And just to get rid of fractions, if I take this 5 up to the other side, then we don't have fractions. So if I take that, divide 5 across to be times 5, we would have, let's just get the real components here. A plus 2b, that's the real components. And the imaginary components is negative 2a plus b, or b minus 2a. And on the right hand side, I'm going to take that 5, multiply it across here to be like that. So I've taken the negative 3 times 5 and the I times 5. Now if we match the real components, we've got a plus 2b, that equals negative 15. Call that equation 1. And then we match the imaginary components. So we've got b minus 2a is equal to 5. And I'm just going to adjust these and put the 2a, negative 2a here, negative 2a there, and the plus b here. Negative 2a and the plus b. And let's double equation 1. So if we double equation 1, we get 2a, 4b, negative 30. And now if we add these two equations together, we get, I'm running out of battery, I think. We get 5b and negative 25. Therefore, b is negative 5. And substitute b is negative 5 into any equation. I'll just put it into, say, equation 1. And we get a plus 2 times negative 5 equals negative 15. A minus 10 equals negative 15. A equals negative 15 plus 10. And we get a equals negative 5. So there we have it. Our solutions are a equals negative 5 and b equals negative 5. Well, I hope this has helped. Until next time, stay happy.